Hi students, welcome to today's class. In the previous class I have explained angle between two curves. Now another concept today that we are going to discuss is tangent, subtangent, normal and subnormal. What are tangent, normal? We already known that. What is subtangent, subnormal? That also we are going to see. And what is their lengths? What is their lengths? That also we are going to see. Okay now. Let us see the diagram first of all. So this is a x-axis and it is a y-axis and it is a origin. Okay. Let us consider a curve. This is a y is equal to f of x. Let P be a point on the curve. At P, let us draw a tangent. Let us draw a tangent. Let this tangent intersect the x-axis at N, Pn. Let us draw a normal to this tangent. Let us draw a normal. So, this is the normal. Okay, this is the normal at the point P to the curve y is equal to fx. Let it intersect the x-axis at M, Pm. Okay. Let us draw the perpendicular. Let us drop the perpendicular. Let us call it as a PA. Let us drop the perpendicular PA on x-axis. See here. Pn, it is called the length of the tangent. Pn is called length of the tangent. That means the distance between the point to the tangent where it intersects the x-axis. It is N. This Pn is that length is called the length of the tangent. Pm is there? No, Pm. This Pm is called length of the normal. This Pm is called length of the normal. What is length of the normal means what? It is the distance between the point P to where that normal intersect x-axis. Okay, na? Where the normal intersect x-axis at M. Okay, Pm is the length of the normal. Now this NA is there. No, this NA. NA is the length of the subtangent. Subtangent, and this AM is there, no? AM. This AM is length of the subnormal. Length of the subnormal. That means what? This is a tangent, this is subtangent. This is normal, this is subnormal. Understand this? Tangent, this is length of the tangent, length of the subtangent. Length of the normal, length of the subnormal. Understand? So, these are the concepts of this tangent, subtangent, normal and subnormal. Now, one question arises. One question arises here. Sir, if for example, if there is a curve is like this, if P is a point here, the point P does not intersecting x-axis here. That means the tangent is parallel to x-axis. Parallel to x-axis. Then what about length of the tangent, length of the normal, length of the subtangent? What about that? The first thing, the length of the tangent is not defined. The length of the tangent is not defined. So, if the tangent intersects the x-axis, if there arises a point of intersection, then only the distance between this point and N, that only then we defined as a length of the tangent. If does not intersects the x-axis, then the length of the tangent does not exist. Does not exist. Length of the tangent is not defined. Now let us take the normal. As length of the normal will be there, Pn. So this will be the length of the normal. Understand this? There is no subnormal. So, there is no subtangent, nothing will be there. Only the length of the normal only will be defined. No subnormal, so no subtangent, no tangent. That's all. Understand this? Right. The second case, if the tangent is parallel to y-axis, let us see what happens. So here this is a curve, this is a curve. Here the tangent is parallel to x-axis, y-axis. So here P and it is some n, Pn. The length of the tangent will be defined, Pn. The length of the tangent is defined. Whereas the length of the normal, this is a normal, it is not defined. Length of the normal is not defined. Okay, now. So only the length of the tangent only defined, no length of the normal, no length of the subtangent, no length of the subnormal is defined. If the tangent is parallel to x-axis, only length of the normal defined. If the tangent is parallel to y-axis, only the length of the tangent is defined. Here length of the normal defined, here length of the tangent is defined. That's all. Remaining all three is not defined. This is the case, that means all the three cases we have seen. Here the tangent parallel to y-axis, here the tangent parallel to x-axis, tangent 2 parallel to y-axis, here the tangent neither parallel to x-axis nor parallel to y-axis. Definitely it intersects x-axis. Okay, now we are going to see there are some explicit formulas are there, detailed clear-cut formulas are there to find this length of the tangent, length of the normal, length of the subtangent and length of the subnormal. Let us see those formulae. Welcome back to this concept here. So let us take here there is a curve y is equal to mx, y is equal to f of x, y is equal to f of x is a curve, let p x1 comma y1 be is in a point. Let the slope of the tangent m is equal to dy by dx at the point of contact x1 comma y1. M is equal to dy by dx at the point of contact x1 comma y1. So here m is what? Slope of the tangent. So the length of the tangent is given by so here x comma y, the point of contact is x comma y, modulus of y by root of 1 plus m square by m, where m is the slope of the tangent, y is the point of contact y coordinate. Length of the normal is equal to modulus of y into root of 1 plus y square. Length of the tangent modulus of y by m. Length of the subnormal modulus of y into m. Length of the subnormal modulus of y into m, where y is the point of contact y coordinate, m is the slope of the tangent at that point of contact. That means what? To find the length of the tangent, length of the normal, subtangent, subnormal, we want y coordinate. In point of contact, we want y coordinate. And the second one is the slope of the tangent at that point of contact. If you know those two values, we can find out all the length of the tangent, normal, subtangent, subnormal. Okay, now? So I hope that you understand these formulas. Then how to remember this means tangent, normal. Here m will be there divided by m, here not m. Tangent, subtangent, this won't be there. Y by m, y into m. Y by m, y into m. Okay, now? Like that you can blindly remember this formula. So let us see some basic formulae, basic problems based on these concepts. Okay, now? Hi students, welcome to this problem. Determine the value of P such that the subtangent and subnormal are equal for the curve. So immediately remember the formula. Subtangent means y by m, subnormal means y into m. Of course, modulus is equal to. Understand this, subtangent and subnormal. Let us see that. So here given that y is equal to e power px plus into px. First to find out the x comma y. So this is x comma y, therefore y is equal to 1. Already we know that y is equal to 1. We have to find out m. M means what? Slope of the tangent at the point 0, 1. Now what is dy by dx? So dy by dx is equal to, this is e to the power of px. E power px derivative is e power px, again px derivative p into px derivative m. Therefore, what is the slope of the tangent? M is equal to dy by dx. We have to substitute 0, 1. Wherever x is there, substitute 0, e power 0, that is equal to 1, p plus p, that is equal to 2p. Understand? P into 0, 0, e power 0, 1, that means p remains, p plus p, 2p, m value is equal to 2p. Now, we know that subtangent is equal to, length of the subtangent is equal to length of the subnormal. So, what is the length of the subtangent means what? Y by m, modulus of y by m is equal to, this is y into m. Understand this? So, from this y value is 1, so this is a y value is m value is equal to 2p, this is a 2p is equal to 1 into 2p. So, 2p into 2p, 4p square is equal to 1. So, from this p square is equal to 1 by 4, p is equal to plus or minus 1 by 2, p is equal to plus or minus 1 by 2. So, very easy problem this is. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. Find the length of normal to the curve x is equal to y is equal to. Here the equation of the curve is given in parametric form. Okay, now, so what is a parametric form? So, we want to find out dy by dx, nothing but dy by d theta divided by dx by d theta. What is dy by d theta? So, differentiate this with respect to theta. So, here a 1 derivative 0 minus cos theta derivative minus sin theta, already minus is there, plus sin theta divided by, here a into, we have to differentiate with respect to theta. So, theta derivative is here 1, sin theta derivative cos theta. Okay, na? So, do not try to simplify this. So, let us cancel this. At theta is equal to where we have to find out pi by 2. So, therefore, what is the slope of this tangent? M is equal to 0 sin pi by 2 by 1 plus cos pi by 2. Sin pi by 2 is 1, 1 plus cos pi by 2, cos 0, 0, that is cos pi by 2, 0, that is equal to m value we got. Next, what we have to get? Y value. So, y is equal to a into 1 minus cos pi by 2, a into 1 minus cos pi by 2, cos pi by 2 is equal to how much? 0. So, total a. Understand this? Now, we are asked to find out the length of the normal. So, length of the normal is given by the formula modulus of y into root of 1 plus m square. If it is by m, tangent will come 1. So, therefore, here y value is m, a plus 1 plus m value is equal to how much? 1. M square means 1, 1. That means root 2a. Root 2a is the length of the normal. Very easy problem this is. I hope that you understand this solution. Let us move to next problem. Welcome to this problem. For the curve x to the power of m plus n is equal to a to the power of m minus n into y to the power of 2n, prove that the mth power of the subtangent varies as the nth power of the subnormal. Subtangent, subnormal. So, subtangent is y by m. Subnormal is modulus of y into m. Subtangent, subnormal. So, those are the two formulas immediately you have to remember. Let us coming to the solution. What we have to prove that mth power of the subtangent varies as the nth power of the subnormal. That means what? Subtangent to the power of m varies as the subnormal to the power of n. Subtangent to the power of m. Variance means it may be directly proportional, may be inversely proportional. That means what? Subtangent whole to the power of m is equal to k times subnormal whole to the power of n. That means what? If you are able to show that subtangent whole power m by subnormal whole power n is equal to some constant, the problem is over. Some constant. It is a constant. Okay, now let us see that. Subtangent whole to the power of m by subtangent whole to the power of n is equal to some constant. The problem is over. So here where k is a non-zero constant. Okay, now right. Now coming to, so to find out subtangent and subnormal, we want y value and m value. Okay, now so let us find out the dy by dx. M means what? M means the slope of the tangent. So let us see that. So here it is given that x power m plus n is equal to a power m minus n into y power n. Before finding derivative, so let us take the logarithms on both sides. So therefore m plus n into log x is equal to log of a power m minus n plus 2n into log y, 2n into log y. So differentiating with respect to x on both sides, therefore m plus n by x is equal to, this whole thing is 0, 2n into y. Log x derivative 1 by x, log of a power m in total constant, 2n into log y derivative 1 by y into y derivative dy by dx. So from this what is our dy by dx? Log y derivative 1 by y derivative dy by dx. From this what is our dy by dx? So dy by dx is equal to y times m plus n by y times m plus n by 2nx. 2nx. dy by dx is equal to y times m plus n by 2nx. This is the dy by dx. That is the slope. Okay, now from this what is our y value also we require. Y value is equal to how much? From this y power 2n is equal to, y power 2n is equal to x to the power of m plus n by a to the power of m minus n. A to the power of m minus n. We want y only. So y is equal to x to the power of m plus n by a to the power of m minus n whole to the power of 1 by 2n. Okay. So this is our m value and that is we got a y value. Let us substitute here subtangent and subnormal formula. Let us get one constant so that we can prove this result. Okay, now let us continue the solution. Welcome back. Let us continue the solution. So we got this m value. So what we have to prove? That mth power of subtangent, subtangent whole power m by subnormal whole power n, subnormal whole power n. Subtangent formula y by m, that means what? dy by dx. Otherwise we can put is no problem, y by m whole to the power of m. Of course this m and this m are both are different, better you use dy by dx. Okay, now so this is equal to y by dy by dx whole to the power of m by subnormal y into m, y into dy by dx whole to the power of n. So if you observe here y power m, here y power n. First concentrate on y power m, y power n, a power m by a power n, a power m minus n, y power m minus n by, this is dy by dx whole power m, this is dy by dx whole power n. Both this also denominator, this also denominator, denominator into denominator. So therefore dy by dx whole to the power of m plus n. Understand? Very clear. So this is a y by m subtangent. Where is subnormal? Subnormal y into m. Okay, now y into m, right. So this is equal to y power m minus n by, what is our dy by dx? M plus n by 2n, that means what? M plus n by 2n into y by x whole to the power of m plus n, whole to the power of m plus n. Okay, now let us see. Let us separate this. So, this is equal to y to the power of m minus n. So, this is equal to m plus n by 2n whole to the power of m plus n. So, this is equal to y to the power of m plus n by x to the power of m plus n. So, this m plus n will come for both the numerator and denominator. Again a power m by a power n, a power m minus n. So, this is equal to again x to the power of m plus n will come in the numerator, x to the power of m plus n into y to the power of. So, this is a minus m minus n. Plus m minus n cancel, minus 2n will be there, that will be in the denominator. So, therefore, m plus n by 2n whole to the power of m plus n, this is y to the power of 2n. Understand this? Once again, a power m by a power n, m plus n minus m minus n, plus m minus m will get cancelled. So, I will write here, if you combine this, minus m minus n will come, plus m minus will come, minus n minus 2n, minus 2n will be in the denominator, y to the power of 2n. So, in this place of y to the power of 2n, in the place of y to the power of 2n, so here see here, x to the power of m plus n by y to the power of 2n is equal to how much? X to the power of m plus n by y to the power of 2n is equal to how much? A to the power of m minus n. Therefore, up to here we can write down a power m minus n, a power m minus. See here, the ultimate answer is a power m minus n by m plus n by 2n whole power m plus n. Is there any x value, y value? Nothing is there. It is independent of x and y. That's why this is a constant, some constant k. So, what we proved? So, subtangent, mth power of subtangent divided by nth power of subnormal, we proved one constant. Therefore, so the result mth power of the subtangent varies as the nth power of subnormal. Okay, now. So, I hope that you enjoyed today's class with some more topics. I will stand before you tomorrow's class. Until then, all the best.